two lines in which each line will have 16 characters to be displayed, and each character box will be made up of size 5 cross 7 pixels. So in total, the LCD that we are going to display using 8051 is going to have 18 characters that could be displayed, 16 characters on the first line and 16 characters on the second line. Maximum of 32 characters can be displayed, right? Okay. So before getting into 8051, why we need to interface with 8051, we need to understand that LCD cannot work on itself. Whenever we want to display any data on LCD, first we need to send that data which needs to be displayed through one of the processor. May it be through microprocessor, may it be through microcontroller or ARM processor, whatever. So the data that needs to be displayed on LCD should be sent from one of the processor. In this particular learning, we will send the data from 8051 microcontroller, right? Therefore, LCD cannot work on a standalone basis. It needs to be controlled, it needs to be executed only through the microcontroller in this particular case. Okay, we shall first look into what this LCD module will have. This LCD module, as I said, will have 16 characters into two lines in each of the is the total display quantity that it will have. And now whenever you need to display the LCD, first you need to configure the LCD and then display on it. Without configuring LCD, you cannot display the data directly on LCD. So as to configure the LCD, there are commands that needs to be sent to the LCD. And these commands will be a hexadecimal commands that needs to be sent from microcontroller to the LCD panel, right? So we'll look into few of those commands that needs to be sent before displaying any of the data on LCD, right? So we have here LCD command codes. Again, I said that these LCD command codes are 8-bit hexadecimal LCD codes that needs to be sent, right? So 38H is one of the LCD command which tells LCD that for a display we are going to use two lines, and in two lines each of the character will make use of 5 cross 7 matrix, that is this particular unit. This particular unit will have 5 cross 7 pixels to display each and every character, right? So that only when we send 38H, these two lines gets configured in LCD, right? Okay. Similarly, if we send 0EH to this LCD panel, then display gets on and also cursor starts blinking. All these are preliminary arrangements that you need to make before displaying a character or before displaying any data on the LCD, right? So this is also a must. You need to send 0EH so that the LCD panel gets on and start blinking a cursor, right? Now the second thing is whether the cursor should blink on left side. The data should start getting displayed from left to right or from right to left. For that also you will have a particular commands that needs to be given well in advance. Okay, and 01H will clear the display. For example, the previous data is already displaying on LCD. You would want to remove it. In that case, before you display any of your data, you need to clear the display screen. For that, you need to send 01H to the LCD. Similarly, 06H will increment the cursor by one position from left to right. So you have already chosen, this means that you have chosen to display the data from left side onto the right side, and every time each character gets displayed, the cursor moves by or increments by one position, right? That's what 06H will do. And 2H will return home. It is just like a enter, you get into the second line. Fine? 04H, decrement cursor. The cursor can also be moved from right to left if you would want. In that case, you will have to use 04H. For a display, either you will have to use 06H, in which case it will move from left to right, or you will have to use 4H, in which case the data display will move from right to left. Similarly, if you want to put off the display, then 08H needs to be given, display off, cursor off, and C0H is used to make the cursor start from the second line. For example, you have displayed only 4 characters, and then you don't want to display the next character on the 5th module, 5th unit. Instead, you would want to come to the next line. In that case, what you can do is you can use C0H, in which case the cursor will be forced to start from the second line, right? Like this. Not only these many commands, you can look into the textbook Muhammad Mazidi. There are at least 20 to 30 commands that you have. The various commands are there. What I need to tell you here is, before you display anything on the LCD, you need to first send the commands to the LCD, right? So this will be the first part that you need to do. Okay, we shall now look into the interface diagram, wherein the LCD 16 character with 2 lines is interfaced with 8051 microcontroller, right? And I said that the characters are displayed. For any character to be displayed, you need to have 8-bit data. You know that the ASCII code of characters is of code 8-bit. So if you would want to display A here, you will have to send the ASCII code of A so that it gets displayed. To send the ASCII code of A, you would require 8-bit, and here that 8-bit data gets displayed as A. Okay. So ultimately what I am trying to say is, either you send the command, or either the data that needs to be displayed you send from microcontroller, you require 8 bits to be sent from microcontroller to the LCD display. Therefore, you require one complete port to send the data. That data could be the command, or that data could be the data to be displayed, right? Whatever it is, that data requires 8 bits, and you will have to send it through one of the complete port, and in this particular case we have made use of port 1, means port 1.0 to port 1.7. All 8 bits are used, and they are connected to 8 bits that are there in LCD panel. That these are called as data bits, DB0 to DB7. There are 8 data bits. These 8 data bits accepts the data which is coming from 8051. Now it accepts the data without knowing whether the data which has come is a command or the data that needs to be displayed. So whatever, in both the cases they are accepted through DB0 to DB7. Now the question arises, whenever the data comes from 8051 to LCD, LCD should understand whether that data which has come is a command or a data that needs to be displayed, right? If it's a command, it gets executed as a command. If it's a data that needs to be displayed, it needs to be displayed, right? So to understand that, again microcontroller will send one of the signal to this particular point called as RS. This RS stands for register select. Means microcontroller, before sending a 8-bit data, it has to select one of the registers through RS. If RS is 0, it selects command register. If RS is 1, it selects display register, right? What it means, if 0 is selected, if 0 is sent on P3.2, because in interface you can see that P3.2 bit is connected to RS. If you are setting this P3.2 bit, what happens? You are sending 1 on this line. If you are sending 1 on this line, register select becomes what? What RS will receive? Register select will receive 1. What does it mean? It means that it is a display register. Means it says that whatever data which is going to come on DB0 to DB7, this 8-bit data, put it into a display register. There will be 2 types of registers which will be there in LCD display. it will be either the command register or a display register. If you are sending a command, you should ensure that it gets into a command register of LCD. If you are sending the data, you should ensure that it gets into a display register, right? What happens then? Whenever the command comes here and it gets stored in a command register, inside the command register it gets automatically executed as a command. If it is sent only to command register, inside the command register it will be executed as a command, otherwise not. Therefore, RS needs to be 0 if you want to send the 8-bit data as a command. Okay, right. Similarly, if you are sending a data and you want to display it, in that case, whatever comes to DB0 to DB7, that has to be stored where? It has to be stored in a display register, and whatever gets stored in display register will soon be displayed on the LCD panel. So ultimately, from 8051, your job is to send the command. Your job is to send the command and configure it. After that, send the data and display it. When you are sending a command, you should ensure that the command is sent to command register. It gets stored in command register by selecting RS equals how much? 0, right? And when you are sending the data later on, which needs to be displayed, in that case, it has to be sent on, you will have to see to that register select should be 1 so that it gets displayed later on, right? So from a 8051, only thing is send the data, may it be command, may it be data, and select the appropriate register, right? Okay, fine. Then apart from that, we see that there are another two control lines, read bar write control line and enable control lines, and those are interfaced with P3.3 and E is connected to P3.4, right? What does they mean? Means whenever the data is sent to a LCD, it is from a perspective of 8051, the data is written into the LCD display, in which case this should be 0. Whenever 8051 is sending a data, to LCD, it should get written into one of the registers. So this particular line should go as 0. Then only the data will flow from 8051 to LCD. Okay, so that has to be ensured. This all the time needs to be at 0. That you keep in mind. Enable signal. See, this particular LCD module needs to be enabled before you interface 8051 with this particular LCD. Therefore, what you do, first you select the register, then enable, and then send the data. This is the procedure. First select the register, then enable the LCD, and then send the data. Now, how to enable LCD through 8051? It should be like this. Enable signal should be, you send one on P3.4, create a delay, and then immediately send 0. Means it should be a lower level triggered signal. Okay, so when you send this particular signal on enable pin, upon receiving it, LCD module gets activated and it accepts the data which is sent by 8051. So this is how the overall setup is, and apart from that, you should also know that for LCD to work, since it's again a digital display that we are talking about, the one which gets displayed through pixel is a digital display, and therefore you need to provide 5 volt supply through VCC and VSS. VSS will be ground, VCC will be plus 5 volts. There is one more pin called VEE, and you will have a knob for VEE. When that knob is rotated, actually it is a pot. You are adjusting the register, and when you turn that knob, the voltage between 5 volts to 0 volts, it gets varied, and accordingly the brightness of the display gets adjusted. You want lower brightness, then you can turn the knob, right? So for that VEE is there. So all in all, there are 8 lines which are data lines interface with 8051, 3 control lines and 1 VEE line. So VEE line is to adjust the VEE line is to only adjust the brightness. These 3 are to select the register, write procedure and enable the LCD module. And the data gets from P1 port 1 to DB0 to DB7, and whatever data comes here either gets stored into the command register or it gets stored into a display register. If you have sent a command, then make it store it in command register, and once it gets stored in command register, it executes as a command. For example, if you send 38H now, if the 8-bit value that you have sent is a 38H and you make RS equals 0, then this particular data gets stored in command register, and once it is stored in command register, it executes automatically inside the command register, and the 2 lines are activated, and whatever data that you send later on for a display can be displayed now on both the lines with 5x7 matrix composition, right? So this is what I wanted to explain the theory. Next we'll take up a program of this interface and discuss that. Thank you. We'll get into the programming part of this. See, here is a program that we have written for LCD interface. Before I start explaining you the program, let's again look into the interface that we have. You can notice that P3.2 is connected to register select, P3.3 is connected to read/write mode, P3.4 is connected to enable signal of LCD. Apart from this, port 1 is connected to the data lines DB0 to DB7 of LCD. Keep these things in your mind because it's required for us later on. And what did I say? I said that LCD can be interfaced in 2 phases. First phase, we are sending all the commands to the LCD. We are configuring the LCD. Once LCD is configured and ready to display, then in the second phase, we send the data that we would want to display, right? So LCD interface is delivered, is executed in 2 phases. In first phase, you send all the commands, execute the commands. In second phase, once all the commands are sent and configured, then you can send the data that you would want to display, right? So, okay, in that context, we'll come back to the program. See that we are again originating at 0000H, and you can see straight away that I am trying to send 38H to LCD. What did I say the 38H is? I said that if you want to select LCD with 2 lines and two lines with 5x7 matrix of each character display, then we should go for 38H. So in that very same context, we are first sending the codes. We are sending the code 38H, the command 38H, and then we are taking it into the accumulator, and then I think delay should not come here. Fine. Okay. It should be call command. Once I have taken into the accumulator, I'll call a subroutine called as COMWRT. Now, what is this COMWRT? It's a subroutine. It's a function wherein we are going to store it into a command register. I told you that whatever code we send from the microcontroller, when it comes to DB0 to DB7, later it should get stored in where? It should get stored in command register. That will take care, all those required instructions will take care in the subroutine or in the function called command write, COMWRT. So what happens here? It jumps as soon as you call a subroutine. What actually happens, you know that how the subroutine works. As soon as the subroutine is called, it jumps to the subroutine. Where is this subroutine written? COMWRT. This subroutine is written outside the main program. The main program ends here. You can see that the main program ends here, and always subroutines are written outside the main program, right? So it jumps here, here it jumps and starts executing these instructions. Upon encountering return, what it does? It has serviced this particular subroutine by executing it. Upon return, it will jump back exactly to the next location from where it had jumped, right? It had jumped from this location, so it had come here. It will execute all these instructions, and upon return, it will jump back to the instruction exactly next to the place from where it had taken a jump, right? So now, when it jumps here, what we are supposed to do? It is still there in the accumulator, and can I send from the accumulator to DB0 to DB7? No. I should know which lines from 8051 are connected to LCD display. It is port 1, port 1.0 to port 1.7. All 8 bits of port 1, they are connected to DB0 to DB7. So what I should do is the command which I have taken into the accumulator, from accumulator I should send it to port 1, right? So that's what I am doing here. See here, from accumulator I have 38H, the first command, that I am putting it into port 1. So when I put this into port 1, the data 38H is here. Has it traveled here? No, not yet. Unless and until you enable this signal, this data will not be accepted by DB0 to DB7. Therefore, once you are ready with your data, you should configure these three lines, these three command lines, these three control lines. Okay. So what you do here is you clear P3.2. What do you mean by clearing P3.2? What actually the P3.2 is? P3.2 is connected to register select. What is this 38H that you are trying to send? The 38H that you are trying to send is a command, not the data to be displayed, right? Therefore, the register select should select the command register. If it has to select the command register, RS should be 0. If it has to select data register, in that case, RS should be 1. Now, since it is a command, the data which arrives here should get into the command register. Therefore, register select should be 0. So what will you do in P3.2? Because P3.2 signal flows into RS, right? RS will not generate signal of its own. It will take a signal from P3.2, and therefore you are going to clear. Can you see here? You are going to clear P3.2. Therefore, you are saying that RS equals 0. Means you are making LCD select command register, and whatever now comes in DB0 to DB7, after LCD gets enabled, whatever comes from port 1 to DB0 to DB7, that data gets stored in command register. Fine? Okay. Next, what is the second thing that you need to do? You need to configure this particular line, read/write. Whether 38H is written into the LCD or 38H is read from the LCD. It is written into the LCD. Therefore, this P3.3, this particular line should be made 0. Means write bar should be enabled so that the data can flow from port 1 to DB0 to DB7. In that context, you are clearing P3.3 so that the 0 flows into the right signal, right? Have we done? No, we are not done yet. We need to still configure enable signal. And what did I say? How to configure the enable signal? Through this. That is level triggered, low level triggered signal needs to be generated. Means to say that I need to send 1 and then create a delay and then I need to make it 0. And where should I do this? I should do that on port P3.4. Therefore, you can see here, initially I am setting P3.4, means I am making that P3.4 as 1 and then calling a delay. What is happening now? Already from the main program, a subroutine is called and it has come into a subroutine program. It is executing a subroutine program. Inside the subroutine program, there is one more call of a subroutine. So subroutine is now called. So what will happen now? The execution will jump to a delay program. Means from here, it will again take a jump to here. Already from command right, it had taken a jump here, and again from here it takes a jump here. It generates a delay program. I don't want to explain now the delay program here. It is nothing but a loop within the loop, and some sort of milliseconds or microseconds, sorry, not milliseconds, some microseconds of delay is generated here and return is encountered. When return is encountered, what happens? The execution comes exactly to the next instruction from where it had taken a jump, right? So it will come back to this position. And see here, you had given 1 to P3.4. Now you have created a delay. What you should do now? You should make P3.4 go to 0. Therefore, clear P3.4. By doing this, what have you done? You have sent this particular signal on P3.4 to a LCD display, and now that LCD display has got activated, it knows that something is going to be written, and whatever is going to be written into this DB0 to DB7 should be stored into command register, and once it gets stored into command register, it gets executed in the command register. Therefore, till here, till this point, 38H gets executed in LCD, right? What happens when 38H gets executed in LCD? The two lines gets activated. Means you can display the data on both the lines, and each character where it's going to be displayed will be of size 5x7 pixel matrix, right? Okay, so after this 38H is executed, you will return back. What you have executed one command, now you will return back. When the return is encountered, where will it go? It will go to exactly the next instruction from where it had taken a jump. It had taken a jump from this point. Therefore, it will, upon return, it will come back to the position exactly to the next instruction from where it had taken a jump. Right. One instruction is, now one command is executed. You would want to execute the second command, 0EH. What is 0EH? Cursor on, display on, cursor on. You would want to make this. You have enabled this. Now you would want to put on the display and cursor blinking, right? So what you do here is you call for 0EH. We have discussed that 0EH stands for display on, cursor on. So now this needs to be executed. You take this into accumulator and again call the same subroutine, command routine, subroutine, so that it again jumps to the same command subroutine. And here we know that whatever data we are sending is a command, therefore it needs to be sent from port 1 only. Therefore, whatever is there in accumulator, that is 0EH is there in accumulator, you send it into port 1, right? After that, now you should tell the LCD whether this 0EH needs to be displayed or whether this needs to be executed as a command. This needs to be executed as a command. Therefore, you will have to again make the register select as 0, therefore P3.2 is now made 0 again. You are again making the right signal, and again you are generating this signal to enable the LCD, and therefore whatever is there in port 1 now, which is 0EH, comes into DB0 to DB7. From DB0 to DB7 it gets stored into a command register, and inside command register 0EH gets executed, right? So once it is executed, you will return back. You will return back where? Exactly to the next location from where you had given a from where you had taken a jump. From here you had taken a jump, so it will come back exactly here. Again, delay is not required here, or if you give delay also no problem. Again, I would want to execute 06H. Similarly, I would want to execute 84H. Like this, I execute all the commands first, and accordingly I will configure my LCD before I display anything on this particular LCD screen, right? Once I am done with all the commands, here I have executed 38H command, 0EH command, 06H command, and 84H command is not required exactly. 84H will make the LCD display start at the middle from the 4th unit onwards. If you want, you can take it. 84H will make the screen start from this particular display unit. If you want, you can do it, or just for showing purpose in this particular program, 84H is also executed. After this, here you can see that now, since all the commands are executed and LCD is now ready to display the data, now from 8051 we start sending the data that we would want to display. So here I am sending N into accumulator. What happens here? Actually, the ASCII character of N gets stored into accumulator. After that, this time I will call one more subroutine, but not the command write, but this time I will call the data write. Means this time I would want to execute RS equals data register, not command register. Therefore, I will get into one more subroutine called data write, and when I execute this, when the execution comes across this, it takes a jump exactly to this particular subroutine. Again, this subroutine is written outside the main program, that you will have to observe. Any subroutine, any function will be written outside the main program. This is one of the subroutine, data write is one of the subroutine, delay is one of the subroutine. We have 3 functions or 3 subroutines which are outside, which is written outside the main program, and from the main program, when we call data write, we jump into the location where exactly this particular subroutine is written, right? Here what we need to do, this time whatever is there in accumulator, we again take it into port 1, because the data that needs to be displayed again sent from port 1 itself. Therefore, the accumulator content, which is N, I wanted to display N, I had taken it into accumulator. From accumulator, I will send it to port 1, so that from port 1 only it will come to DB0 to DB7. Okay, but this time what do I need to do? This time I need to set P3.2, which is RS, as display register, not as command register. To make register select as display register, what should I do? I should make RS equals 1. This time I need to make RS equals 1. Previously, when we were executing the command, we had made RS equals 0. This time we will make RS equals 1. So come here, you can see there P3.2 which is connected to RS is set. So we are making that particular signal go as high, and from there again Are we writing the data from port 1 into the LCD? Yes, we are writing the data. Therefore, we need to set write signal enabled. W bar we need to enable. Therefore, P3.3 again we are making it clear. And again for that data to come to LCD display, we need to enable this particular LCD signal, and again the same procedure. We'll put 1 into P3.4, we'll put 1, call a delay, and again we'll put 0. That we have done here. Set P3.4, call a delay, it will come here, delay program gets over, again it will come back, it will clear P3.4. So that this signal is created, and now LCD is ready to take the data, and this time whatever data comes from port 1 which is taken into DB0 to DB7 will be stored in data register, not in the command register, and whatever is stored in data register gets displayed as will get displayed on the LCD unit. So this is how the program needs to be executed. Thank you.